Good evening, everybody. I believe you can hear me. So if you can hear me, kindly respond. All right. So promise you're the only one connected yet. And if you can hear me, kindly give me an indication that you can hear me, so that we can have this class as promised. If you can hear me, unmute your mic and respond. Let me know what I'm doing. All right. So today we are going to look at organic chemistry 3. And in our previous class, we looked at organic chemistry 1, organic chemistry 2. It was a wonderful class, and I hope that this will be a marvelous class as well. I will need this class to be very interactive, and for that, I've put measures in place, and I have extracted 2 JAMB questions for you all to respond to. And number 1 is carbon atoms in ethene are dash hybridization at dash carbon atom hybridization. So in our last class we covered something like this. So and I appreciate that you unmute your mic or you type and respond quickly. I'm waiting. I'm waiting. Can someone respond? People learn to forget. Promise. Who else is connected to this live? Red Gem. Favor. In the last class we covered something like this, And if people are not responding, I'll be forced to end the class. Carbon atoms in ethene are dash: A, sp hybridized; B, sp2 hybridized; 3 sp3 hybridized; then D, dsp3 hybridized. I need an option. People cannot hear me. Now, those of you that is connected to this, like, unmute your mic and start talking.
SP hybridized.
B, sir, sp2 hybridized.
Okay. A minute. Let's have this class. Promise, why are you not saying anything? Okay, so we'll move to the second question. The answer is A. If you like, take it serious. Now, the next question, the ability of carbon to combine with one another to form straight branch or ring structure is called dash. Quickly, I need an answer.
D, catenation.
Okay. So, here's a warm up for you guys. In our last class, we name organic compounds, right? We'll look at rules. So, I'm going to reduce this a little. We look at rules in naming organic compound. Yeah, so here is an organic compound for we to name. So I want to draw your attention to this. So quickly, okay, let me look for my tools. So quickly, I was saying that if we have something like this, how do we go ahead to draw? Okay, let me use red. Now, C4, we know, I don't like this mouth. So C4, we know we have 4C, okay? 4C. And 4 carbon atom is called what? Please, I need you people to be interactive. I don't know this one people are doing. 4 carbon atom is called what?
Boot.
1 carbon atom is called met. Somebody is saying something. Is somebody saying something?
Boot.
1 carbon atom. Huh?
4 carbon atom is called boot.
All right, thank you very much. Now we have something like this. So we know that we have 8 hydrogens. Okay. So let's draw the hydrogen on top until we get to 8. This is just a recap of the previous class we had. It's not what we're going to do today. We're going to do something very different. So we have 1, 2, 3, 4, 5. 5 already. I'm going to add 1 here. I'm going to add 1 here. 6, 7, and here I'm going to add, here makes it 8. Now we have 2 space here. Now what does it mean? It means that these spaces that are here, right, forms a double bond. Forms a double bond. And as a result of this double bond, it uses these bonds that are here to form another what? Bond here. So this is making it what? Double bond. So therefore, what will now be the name of this compound? People, students, what will be the name of this compound? What will be the name of this compound?
Bootwine.
No. Okay, yeah, correct. Now, let's call it butene first. Let's call it butene. Why are we calling it boots? First of all, in that class, we said that first thing to do, identify the longest chain. The longest chain is boots, right? And the second thing to do, identify the functional group. Functional group is an alkene group, like is a double bond. So therefore, its name is going to end with what? Tene, and that will have butene. Now, in that class, what I did not tell you, and which I'm going to say it now, is this is the functional group. And in functional group, you are going to respect the position of the functional group. Please try to understand it so that you don't get it wrong. Now, if I'm counting from, this is left and this is right. Now, let me use yellow. If I'm counting from left to right, look at what I'm going to do. I'm going to count 1 carbon and 1 bond. I'll call it 1, 2 carbon and another bond. I'll call it 2. Then this carbon and another bond, I'll call it 3. Then this carbon and this bond, I will call it 4. Okay. Now, let me wipe this off. We're going to take this off. So if I am counting from right to left, what I'm going to do is this. I'm going to count, this is what I'm going to do, this and this and 1 bond. This is 1. I count, attach it to another bond. This is 2. I count, attach it to another bond. This is 3. Then I count the final carbon, attach it to the ending bond, which is what? 4. Now, in that class, I said, which I'm going to repeat again, that when you are naming organic compound, you consider the group. Now, either the group or the substituent, make sure that it is closer to the ending. And we just counted from left to right. Position, this bond position is at the position of 1, 2, 3. Is at position of 3. Let's count from right to left. This position 1, 2 is at the position of 1. So therefore, if we want to name this compound, we'll call it, since we know that the longest continuous chain is boots, so we're going to call it boots hyphen 1, then in. So what I'm saying in essence is this. I am saying that the boots is because it is a 4 carbon atom, right? Then the 1 is because when we counted from right to left, this position is at a position of 1. Okay, so that is why we are calling it 1. Then in is a functional group. Is that understood? People, is that understood?
Yes, sir.
Okay. All right. So okay, we said this is at a position of 1. Okay, so quickly before we go into the business of today, let me quickly draw another one for you guys. So if I have, we've looked for that of double bond. If I now have something like this, and then something like this, then this, let me use red. So let me use red for this. If I have something like this, Favor, since you are the only one responding now, let me quickly ask you a question. Quick one. Okay, let me use my hand so that it will be fast. Pen is slow. So Favor, can you identify the functional group here, even if I have not drawn it completely? What is the functional group of this compound?
Butanol. That is butanol. Butanol.
Are you sure what you just said?
Yes, sir.
Okay, so now the functional group, no, I did not say name the compound. I said what is the functional group? What is the functional group? What is the functional group of this compound?
OH.
OH, which is an alkanol. I told people to read functional group. So which is an alkanol. So what we're going to do now is rule number 1, count the longest, right? Continuous, which is 1, 2, 3, is what's all right. So rule number 2, identify the functional group. Now this time around, the functional group has a position. So you're not just going to name it anyhow. Okay? So let's see what's happening. So this is supposed to be butanol, all right? Now, but the functional group has a position. Now, let's start counting from the side close to the functional group. and that is, let me use yellow. So if we count from here, 1, 2, 3, 4. Okay, if you count from here, at position 3, this is position 3. This is where you will now find the arcanol group. Okay, the arcanol, the functional group. But if we count from here, 1, 2, 3, 4. Okay, at this position, let me use green. At this position, which is position 2, from left to right, or rather right to left. At position 2, this is where you now find what the functional group. So if you are going to name it, all right, so this will now become buta or but 2. Let me remove this but 2 all. Okay, was that clear?
Sir.
All right. So why is it 2? Because this OH is sitting in a position of 2. But assuming that the OH is here, I know I'm taking my time to explain this for you, but assuming that the OH is here, OH is here, and there's no O here. Okay, so this will now become normal butanol. Because if you say but1 or, you are correct because it's at position 1. But if you say quickly, before we move to our subject for today, give me this structure for this, or rather name this compound for me. Promise, name this compound for me. Praise, you're welcome, huh? Name this compound for me. Quickly, I don't have all the time. Have a journey tomorrow. But
Pentane.
okay, who is talking?
Regime.
Praise. Okay, red gem. Okay. Praise. Promise.
Five.
Huh? What is the person saying? What are you saying? Please speak up.
I said pen 2N.
Okay.
Something like that.
Pencil in. Every one of you agreed?
Yes, sir.
Yes, sir.
All right, that was indeed correct. So there's somebody I removed from this group because the person is delaying to identify himself. So I want to quickly adopt the person. All right, so let's continue. Okay, so what I have for you today in store is isomerism. Let me see the number of people active. Risha is not online. Okay, so what is isomerism? Isomerism is the existence of two or more compounds with the same molecular formula but different structure. Now, I don't want you to get it twisted. This thing, this English I just spoke, is very easy. When we say the same molecular formula, so for example, if I have this, and this, I don't want to draw hydrogen so that it will not waste my time. Let me just add this to it. Now, if you look at this very well, reduce. If you look at this very well, I have C4, right? I have C4 and probably have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is H. This is H10. Okay. Now, if I have another arrangement like this, I have C, and C. Please watch carefully. And I have something like this, C. Is it the same or different arrangement? Please, I need interaction. Is it the same or different arrangement? This is A. This one is A.
The same arrangement.
It's different arrangement.
Thank you. God bless you. This is different arrangement. This is a straight chain.
God bless you. This is different arrangement. This is a straight chain.
I don't know why my voice is echoing. What if I have something like this? I call it, this is the first one, this is the second one, this is the third one. Let's say I call this one G. Is G and A the same?
Yes, sir.
Is G and B
Yes,
the
sir.
same?
No, they're different because the last
Same.
no.
Thank you very much. Now, see the idea now. Isomerism is the existence of two compounds. I don't know why my voice is echoing. Of two compounds or two or more compounds with the same molecular formula. Now, if you look at A have C4H10. If you look at G also have C4H10. Okay, let me remove this G. Let's remove this G. G no follow. If you look at B have C4, the same C4, H10. So what is H10? Now, what is isomerism saying? Isomerism saying that when two or more compounds exist, they have the same molecular formula. This is the molecular formula. This is the molecular formula. This one here now, molecular formula. They have the same molecular formula, but different structures. This is a straight chain, and this is something like T. They are not the same, but they have the same structural formula. So properties they differ a little. So isomers have, if you are jotting, note that isomers have same physical property, but slightly different chemical property. And why is that so? Is because they have the same molecular formula, but different structures. Now, move forward. We now have types of isomer. Number one is the functional isomer. Now, in this functional isomer, just like the name implies, this occurs when two or more hydrocarbons have the same molecular functional group. Now, when we say they have the same molecular formula, please note the formula does not change. C4 is C4, but they have different structure. A good example is steroids. Now, ethanol, et is 2 carbon atom, abi? Una know, abi?
Yes.
Et is 2 carbon atom. So this one is an ethanol. I hope I'm still connected to these people. I'm not hearing your voice. So. All right. So this is ethanol. This one now is ethanol. E for ethanol. Okay. Now, what about methoxymethane? Now, methoxymethane will now be something like this. Methoxymethane will now be COCH H on top, another H. Okay. H. Now, this. Now, if you look very well, they have the same structural formula. Sorry, molecular formula. This is 1, 2, C2. Let me use another pen. I'll use green. I'll clean this one. Sorry, clean. So this is C2, abi, C2 H, C2 1, 2, 3, 4, 5, 6. H6, they will now have O. Okay, let's now come in. Now we have 1, 2, we have C2, H6, and we have O. Now, if you look at these two very well, they have the same molecular formula. This is the same molecular formula, but they are carrying different functional group. Like this one now is carrying acanol, and this one is carrying esters. I know you could not read that functional group. No problem. This one is carrying ethanol or acanol. This one is carrying esters. Okay, so therefore, when if an isomers like this occurs in more than more than 2 or more hydrocarbons, right? It is referred to as what? Functional isomerism. Is it clear? People, is it clear? Jambite, is it clear?
Yes, sir.
I have one question.
I cannot hear you people. Is it clear?
I said I have one question.
Okay, yeah. Go ahead.
Okay, yeah. Go ahead.
Okay, so for functional isomers, the two different isomers take different name, right?
Yes, they have different names, but they still maintain the same molecular formula.
But they still maintain the same molecular.
Okay.
Can I go ahead?
Yes, sir.
All right. So that is number one functional group we just look at now. Then Number 2 is chain isomerism. In fact, this one I'm going to do just one, or rather 2, and you are going to draw more. Chain isomerism. And chain isomerism, they have same molecular formula as usual. They must have the same molecular formula. But what is the difference? The difference is always in the arrangement. So, for example, if I have this guy now, for example, if I have this guy, I'm just going to draw the skeleton so that you don't get it twisted. If I have this guy, then how many ways can I draw this guy? Can I say this and this? It's the same thing as straight chain, Nabi. Is it not the same thing as straight chain? Please answer me. This is the first way I drew it, and this is the second way I drew it. Is it not the same? Is it not the same thing?
Is it not the same? Is it not the same thing?
I think the other one is a branch chain.
Promise, look at this thing. I have this. Now, if I bend this one, or let's say I bend this one this way, it's not going to give me the same thing. Well, anytime we talk about branch chain, we are looking at something like this. This is a branch chain, okay? This probably is a branch chain. But whenever you have a straight line, either it is horizontal or vertical, is referred to as a straight chain. A straight chain is referred to as a straight chain. So if it is vertical, if it is horizontal, a straight chain is always a straight chain. Is that understood?
Yes, sir.
Okay. Now, let's go forward. If I now have, I've cleaned it. Okay. If I now have something like this, something like this, because there's a JAMB question, they will ask you, how many isomers does butane have? How many isomers does pentane have? In fact, let's draw for pentane. Pentane is 1, 2, 3, 4, 5. The question will now ask you, how many isomers does pentane have? Now, this is isomer 1. Okay? This is isomer 1. Then isomer 2, like the question is simply asking, how many ways can we arrange this thing that will not have the same structure? So I know I can arrange pentane this way. Let me say I give it, this is 4. 1, 2, 3, 4. Let me put one carbon here. Okay? So this is, these still have the same structure of 1, 2, 3, 4, 5. Still have C5, right? Then how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then H12. Okay? So if we draw it this way, it still have the same formula, which is C5, okay, H12. Now, aside drawing it this way now, is there another way we can draw this one? Yes. Now, if we draw it this way, let's say 3, number 3 isomers of pentane. If we draw it this way, C, 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 C. Now, I want to draw your attention because I put one here. You say, okay, let me put the other one here. It's wrong. Why is it wrong? According to nomenclature of organic chemistry, it simply means according to the naming. If we want to count, remember, we say count from the side that the substrate is close to the end. If we call this 1, 2, 3, 4, this is the branch. So we have to count from here. 1, 2, 3, 4. How do we name this? First of all, yeah, Daddy, are you in Lagos now? No, this is Ogaga. No, Daddy. All right. Sorry for that. I'm really sorry for that. So I was saying that we are going to make a mistake if we think this and this are two different structures. They are not different structure. As a matter of fact, if we name this, start counting from the side that is close to the end. 1, 2, 1, 2, 3. So definitely we count from this side. So this is 1, 2, 3, 4. 4 is 4 is what? But, right? So it's going to be but. Functional group, a single bond, butane. So this is now 1 to 2 methyl butane. On understand that, so 2 methyl butane. On understand that? What I just said now, is it clear, people?
Yes, sir.
Okay. So this structure, if it's not clear, draw my attention, because I'm moving with speed of light. I have a lot of things to cover today till Wednesday. So this structure now, I'm saying this is, we did it last week Sunday, organic chemistry class. We said this is 2 methyl, right? Butane. Let's now name this one. We have to count the substrate or substituent close to the end. So this is 1, 2, 1, 2, 3, 4. So this will now be butane because functional group is alkane, right? Single bond. So this is now what? 2 methyl, what? Butane. So it is similar to this one. So therefore, this one is cancelled. Okay. So another way we can draw this to give us entire different structure. I think let me shorten this, or let me just write this at the top. So another way we can shorten this, let me write this at the top. So it's still the same thing, 2 methyl butane. So another way we can do this is, let's take this off and take this off, and let's put this up and down. So if I put 1C here, I put 1C here, this is completely different. It's different from the first one, it's different from the second one, it's different from the what? Third one. So this still maintain C5, H12. Okay, people, is this clear? So therefore, pentane has 3 isomers. This is pure JAMB question. JAMB is going to ask you which of the following is not a member of the pentane isomer, or is not an isomer of pentane. or which of the following is an isomer of pentane? Now, if we want to name this number 3, it will not be 1, 2, 3. 3 is a prop, right? Single bond, alkane. So it will not be propane. So at position 2, 1, 2, if we count from right to left, 1, 2, it's still 1, 1, right? So this is a 2,2 dimethyl propane. Now we said that when the substrate appear more than once, we cannot introduce prefix. The prefix are di, or rather mono, di, tri, and like that. All right, tx and dec. All right. So since it appeared twice, it will not be 2, 2. Both of them are in the position of 2, up and down. 2, 2 dimethyl propane. Right. So these are the 3 isomers. So you can see that they have different arrangements. Right. They have different arrangements, and different arrangement, but they maintain same molecular formula. They maintain molecular formula. This is what we mean by isomers or isomerism. No matter the structure they assume, they must maintain, they must have the same molecular formula. So if this is clear, which I believe is clear, this night, I don't know if I should give you this exercise, but yeah, I will not give you this exercise. I will give you this exercise. So Melvin, I believe you are familiar with all what you've been doing. So quickly, I want you to how many isomers does this have? How many isomers does this have? Quickly, Favor, Promise, Melvin, Praise, all of you connected. I can see you. Red Gem, Ifan, you are welcome. Tell me, how many isomers does this have? Quickly. About wasting my time. Or are you working? Because none of you are seeing anything. It's so frustrating that I'll be connected to a live class. People are not interactive. Please say something. Cough. Let me know that you are still alive. Let me draw it up. Cough. Let me know that you are active. Let me know that you are interactive. Instead of keeping quiet like that, it's not nice. So Promise, how many isomers? Melvin, how many isomers?
I got just 3.
You got 3?
Yes, that's what I could get out from it.
Okay, I think I just saw something now. This pentane we drew. Is it 3? Okay. You got 3. Okay, let's review it together then. If we have something like this, so this is number 1 isomers first. How can we arrange this differently? So we have this. Let's go for 3. Now, this is another different isomers. Okay, these are another different isomers. If we take away this from the top and put it here, you see the same thing. All right. Now, outside these two, you cannot arrange any other one that you will not go back to this original one. So for example, now if I want to arrange this like this, let's say I want to arrange it like this, then put one C here, then put one C here. I told you like organic chemistry are like bicycle chain. If I hold this end, if I hold this end and I hold this end and I drag, I'll have a straight chain. So this thing is the same thing as straight chain. If you hold and drag, it's the same thing as straight chain. It's not branch. A branch chain is something like this. It's branch in between carbons, right? But this one is not in between carbons. It's free. So therefore, it can be straightened. I just want you to get that. Since it's free, it can be straightened. All right, promise. So which other way we can draw again? We can say, okay, there's no other way, actually. There's no other way. So therefore, this is 1, 2, 3, 4. 4 is butane. Butane have 2 isomers. You just have to note. Butane have what? 2 isomers. So let's move forward.
I wrote it that time. I wrote it just now. I checked it.
But you did not say anything now. You did not interact now. So
no, my this was not working before. I just checked the settings just now before. That's why I wrote a message just now.
Okay. And then somebody I removed from this live class because I told the person to identify himself because I'm suspecting that you are sharing the link to other people. The person did not respond. After removing the person from the group, the person messaged me on WhatsApp and I identify him that is a member of the group. So it's not my fault anyways. I gave him an hour plus to message me on WhatsApp, let me know, at least know who he is, but he did not do that. I don't like people missing class anyway. That's why I'm feeling bad for him. All right, so since we are identified, remember we started with functional isomers. We went to chain isomerism or chain isomers, and then we did one exercise. Then now we have come to the final one, which is called geometric isomerism. Now, geometric isomerism is similar to everything we've been saying, but just that it has its partial arrangement. It still maintains molecular formula. If our molecular formula does not change, any isomers you will talk about in this world, they must have the same molecular formula. Okay, the difference is always at the arrangement. And a good example is the cis and the trans, which I'm going to show you in a jiffy. The cis and the trans. So how do we write the 6? Now, if I have this double bond, I have this, I have this. I believe you must have seen this in past questions. In fact, one of the things that made me stand out during my JAMB class or during my UTME days is that I read things that people on a normal day will not read. Yeah, so that was one of the things that made me to stand out. So if you are still following things that are so familiar in textbook, sorry. Why a lot of people, this should be the first time they should be seeing something like this. But let me ask, how many of you have seen this structure? You've seen it, like you've seen it in past question.
I have.
Nobody? Okay, promise you have seen it?
Yeah, I've seen it.
Yes,
Okay,
sir.
thank God, though. Thank God. All right, so another way we can draw this is, let's say I have CH3. I have CH3. Now, I want you to note something. Ish. Okay, sorry. I want you to note something. Please note it. Whenever you have, this is methyl. In our last class, we did it. So don't ask question. This is methyl. Whenever you have methyl in the same plane, it is called cis. Whenever methyl is in the same plane, it is called cis. And whenever it might not really necessarily be methyl. Okay, JAMB might give you something different. Let's say JAMB can give you something like a let's say NH3 can give you like methane in position of methyl. JAMB can give you NH3 in position of methyl. It can give you anything, but what I want you to know is this: whenever the substituent or the substitute, okay, appears on the same plane, all right, it is called cis. And whenever it appears on different plane, it is called trans. Okay, what did I say? Please echo it. Let me hear it. I cannot hear you people. Or is it pride?
Said whenever the substituent in the same plane is called cis, and whenever the substituent appears on a different plane is called trans.
Trans.
All right, thank you very much. Now we are going to name it. JAMB is going to ask you to name it. So how do we go about this? So it is normal thing you already know. In fact, let me come to this place. Let me just draw it. It's going to take a while, but let me just draw it so that you guys can get proper grasp of what I'm doing. So if I have ish here, and I have let's still go with this 3 H2. Okay, I think it's similar to the structure. Let me see. Yes. So how do we name? Now, see, this thing is still the same thing as it. If I straighten, you just have to have a eye to see some things. If I straighten this compound, right, I have something like this. Abi maybe I have something like this. Or rather, let me clean this three. Let me clean this one. Let me add C. So since H3 is attached, the one H is here, and that H is here. So this is just like expanded, okay? But we can have 1C H3, okay? So let me just clean this for this thing's sake. Now, this thing we have here, we can name it. So this thing we have here, we can name it, can't we? 1, 2, 3, 4. The longest
Yes.
is boots. Is boots, right?
And
That's the longest. Then the next thing is functional group. Functional group is double bond. So it has to be double bond is a alkene, abi? So it has to be
Yes, sir.
butene. But the double bond has a position. count from the side closer to the end. 1, 2, 1, 2. So this is 1, this is 2. Let's count from here. 1 and this is 2. So both of them are 2, 2 if you count from left to right or right to left. Okay, on the same. So this is now
Yes,
boot
sir.
2 what in. On the same boot waiting.
Yes, sir. 2
Boot
in.
waiting.
2 in.
Now, but this is not the original structure. I drew this structure so that you understood how I'm trying to name it, because sometimes you have to have a problem solving skill for you to pass JAMB. You have to have a problem solving skill and you have to be fast as well. Now, since I have drew this thing and I have named it, I have to come back to this. And remember, we said that anytime we have this on the same plane, it is called what? Cis. So therefore, if JAMB asks you to name something like this, the option, in one of the options they are going to give to you is cis. So the full name of this structure is cis boot 2 in. Now do you understand that? Make I clean
Yes.
this one.
Yes, sir.
So the original structure now waiting 6 waiting, boot waiting, 2 in. 6 boot 2 in. Now the 6 is coming from the arrangement telling you that the two substituents are in the same functional group. So since we already named this, oh yeah, people name this one for me. Name this one. Name this one for me. Are they wait to?
Trans boot 2 in.
Huh?
Trans boot 2 in.
Who is talking? Please speak out loud.
Trans boot 2 in.
Trans.
Okay.
Great.
Okay. That's very correct. Trans boot 2 in. All right. So the next thing I'm going to do is so if there's any part, this is the last part that I'm saving. No? So if there's any part you are not clear in organic chemistry, we did organic chemistry 1, we did organic chemistry 2, and this is organic chemistry 3. So if there's any part in organic chemistry that you're not clear, okay, so you can let me know, because tomorrow I'll be going to another thing entirely. So, and I think I need to reserve my battery as well, because I'll be traveling tomorrow, and when I get to my destination, I will power my phone. So trans boot 2 in is correct. Okay, so I'm going to stop sharing my screen so that I can put exercise for you. Then I'll share my screen again, that you answer and name the compound for me before we go. Is that understood?
Yes, sir.
Yes, sir.
All right, so let me stop sharing my screen then. All right. So please name this for me. Are you guys still with me? Still connected. Are you guys still there?
So I'm not seeing you.
But I'm not seeing
You
the
cannot.
question.
Oh, you cannot see.
No.
Oh, okay. I removed it. Sorry. I believe you all can see my screen now.
I got trans pen 2N.
Okay. I'm waiting. Melvin Alpha. Marvin Alpha. Praise.
Trans Epsilon.
Okay. Since Melvin, Favor, Red Gem, Ifine. Okay, Promise just spoke now. Since people are not talking, let's do it together. So the mistake you all made is to count 1, 2, 3, 4. 1, 2, 3, 4. So if it is 4, is both now. So this thing is this 1, 2, 3. This one has 2 carbon. This one carbon, obviously 1 carbon. It now bears a double bond. This one carbon. Then after they will now have C3, right? 1. Okay.
Trans
So
epsilon.
thank you. God bless you. So these will now have 1, 2, 3, 4, 5, 6, 7. And 7 is hept. 7 is hept. What is then the functional group? Is in. Count from the side that is closer to the end. If we count from this side, 1, 2, 3, 4. We got 4. 1, 2, 3. So this will now be 3 heptene. Let's now go back to the original structure. This is trans because I'm in different plane. Trans hept 3 in. Is that understood, guys?
Yes, sir.
All right. So God
Yes,
knows
sir.
that
Yes,
I've
sir.
covered organic
No.
chemistry. Who is saying no?
Hey,
Who is saying no?
I'm the one saying no.
Who is the person? Praise or promise?
Promise. Promise.
Okay, so what's the issue? What's the issue?
Is it that is not compulsory for the hydrogen to be complete?
When it comes to when it comes to
when it comes to
it's not compulsory. Okay, but if it is for regular naming, it is very compulsory.
It is for regular naming,
JAM will not give you a compound without all the except the compound is a triple, double bond respectively. Is that understood?
Yes.
Okay, so just a quick recap. This is where we started from, organic chemistry 1, and in that class we spent time to talk about basic terminology of organic chemistry. Look at the reason why carbon is regarded as a major element in organic chemistry. Spend time talking about them one after the other. Look at terminology, okay? Homologous series, molecular formula for some functional groups. These questions, functional group, and I ask you guys to read more on functional group, and I think in that class we now look at saturated and unsaturated hydrocarbons. Where we say that for saturated hydrocarbons, they only go through substitutional reaction. That's organic chemistry, organic reactions now. All alkanes, single bond, go through substitutional reaction, or you can see elimination reaction. Okay, but this is ethene, or rather alkene and alkyne, they go through additional reaction. And I think in that class I drew some things to explain why I said additional and substitutional reaction. Then we now went further to hybridization. We said for alkanes have sp3 hybridization, and their bond angle is 109.5. Very important, know this. sp2 for alkanes, bond angle 120. Then sp for alkynes, bond angle is 180. Okay, so we look at something like this, a quick question, and we now look at, was it in this class we look at pi bond and sigma bond? Should be in this place. We look at pi bond and sigma bond. Yes, we look at pi bond and sigma bond, but I can't find it here. Okay, so we now went to part 2 that night. Here we now look at, we said for one carbon atom is called met, 2 et, prop, pet, till you get to what? Dec. Rules for naming organic chemistry. First, you select the longest continuous carbon chains. Okay, and for this case, we identify longest continuous carbon chain. I say sometimes you will think that this is branch, but it's not really branch. It could be the longest, so you have to count. So if I count from 1, 2, 3, 4, 5, 6, 7, count from 1, 2, 3, 4, 5, 6, 7, 8. Count from 1, 2, 3, 4, 5, 6, 7. With 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So obviously 7 is the longest continuous. But there are sometimes you have to have, let's say, if this have 8, 1, 2, 3, 4, 5, 6, 7, 8. So this is the longest. So you just have to be careful. It has to be longest continuous. Whether it is branch or branch, it has to be longest continuously. We move further to identify functional groups, single bond alkenes, okay, even alkanones. Okay, so I think in that class, okay, we'll not spend time talking about how methyl are formed. Okay, and we said that let me add one H here quickly. So for methane, they have a shape called tetrahedra. Okay, tetrahedra. Then for alkanes, methyl, they have triangular shape. So we have C here, we have hydrogen. In that class we talked about all these, so just so people wrote it down, you've not forgotten. And this, okay. So moving forward, we now applied rule 1 and rule 2 in naming. So we look at this, and you all named. Look at this, you all named in that class. Then I think we went further to talk about more rules. Okay. Okay. Rule 4. So this here will now say that if the substituent occurs more than once, you have to introduce prefix. Okay, 1 is mono, 2 is di, 3 is tri, till you get to deca. Okay, and then we look at this one, for example. Bromine is at a position of 2. Bromine again is at a position of 3. How do we now indicate it? We say it is 2, 3. Anybody who will see this will know that at position 2 there's bromo, at position 3 there's bromo. Then introduce the prefix di because there are 2. Dibromo. The longest continuous in 1, 2, 3, 4, 5, 10. So you all drew this 2, 3, 3 trimethyl. You all did it, and I think this was an assignment, or rather class assessment for you all. Did this rule number 5 and this. That class was really wonderful, and had a nice session in that class. So with this, I've come to the end of organic chemistry. Tomorrow we're going to look at something completely different. I believe there's no question. All right, so the absence of no question, I'll end the class here. Good night to you all.
Good night, sir.
All right. So I'm just going to stop the recording.
I have one question.
Okay, what's the question?
What does hybridization actually mean? Those SP raised to the power of 2, SP raised to the power of 3, then just normal SP.
Okay. The definition long, but it just has to do with the quantum arrangement. So I think I did not really bother you guys about